Hi everyone, thanks for taking the time to tune into our blog. So today I'm going to go over the machine configuration and machine builder that Autodesk have introduced into the manufacture workspace within Fusion 360. So in order for you to gain access to the machine configuration with the machine builder, then as a user you need to turn on the preview. So if you've been using Fusion in the past, then this might be something you're familiar with, and if not, then up at the top right corner of the application under your preferences area, so if you look for preferences, there will be an area at the bottom of preferences which is dedicated to previews. So preview features, just at the bottom on the left hand side, we can use our drop down list to navigate down the filter, and if we choose the manufacturer, we can go down the list, and if we look for the machine simulation and machine builder, then these two tick boxes will give you access to an environment where you can build your machine in the environment with your material, with your fixtures, with your already CAM setups. Okay, so these machines that you'll be applying will be based around milling, and if we put this on as a preview, then you will have access to build your milling machines within Fusion and add some kinematic movements using the machine configuration as well. So we're going to take a look at that today. And just to give you a bit of a heads up, it might be a good idea to also tick the box next to automatically get latest posts and machines. And the reason for that is because Autodesk are constantly updating this environment just now, and therefore we want you to make sure you're working with the latest. And the latest and greatest will be automatically downloaded if you tick the box next to automatically get latest posts and machines as well. Okay, so let's take a look at this 3+2 milling example that I have gathered from Autodesk. And this basically is already set up. On the left hand side you can see we've already got some operations, and if we want to bring a machine into this environment, then we need to do that through the setup, so the original setup. So when we edit the setup, you can see, and this has been around in the application for a while, but now we're extending the capability because Autodesk have obviously added some more capability with the machine builder, as well as enhanced machine configurations as well. So in order for us to see our machine within the environment that we're so used to with our fixtures and our part and our setup of the WCS and things like that in the beginning, we now have this familiar kind of a setup for the machine as well. So if we select a machine, then that machine will basically be part of our simulation within our workflow. So it will be an added benefit to the fact that we're using a rapid prototyping environment. We want to keep, using our prototyping environment to make sure we're not getting certain clashes with the machine, to make sure we're not going out of any limits. Everything looks and feels like it would in reality. All right. So in the first instance, you may not have anything within your document. As you can see here, the document's empty. We don't have any cloud local machines, but we do have this vast library that Autodesk give us access to. So on the right hand side, we can see that we've got some filters. Those filters are based around capabilities, and those capabilities are based around your machining techniques. And also what Autodesk have done is introduce this as simulation ready, to give you that only list filter, that just gives you the machines that are ready for simulation. So the good thing is Autodesk have been focusing on this for such a long time now that we already have machines in there that are built around very specific vendors, and this is increasing constantly. So we're getting more relationships with more vendors, and we're seeing more machines within this list. Okay, so if we go for milling, for instance, simulation ready, and we pick HAS, then we can see that the box in the top right corner here indicates there's a model attached to that machine. So the image also gives us a very clear indication that there's already a model ready in simulation available for us to bring it into our setup. So if we go ahead and look for the machine that we're actually going to replicate, so today we're going to replicate this type of machine, and it's going to be the Haas UMC 500 SS. It's already in the system, but I want to show you how it can be configured from scratch, okay? So I'm going to select this one just now just to give you an environment that looks very similar, okay? I'm going to download the model and bring it into our already set up, structure with our fixtures and our part. So the first thing it's going to do is ask us to save this simulation model, and the reason for that is because the machine is a 3D model, the same as your fixture and your part. So we're going to save it into your folder. You can have a folder that's very specific for those machines that you're going to be using, and then it will go through a process of setting it up inside your already fixtured setup here. So once it's in place, the first thing you'll notice is you get an extra tab now in this setup, and if we go and select that, we get some positional kind of placements and selection types that we can use to place the machine in a very specific way, okay? If I just show you what the machine looks like, ours is already kind of a setup for a certain configuration, and the reason for that is because I've tried to make it quite simple for the video, guys, okay? So you can go ahead, you've got things like the part attachments, the fixture points, the table attachment, or you've got X, Y, and Z directions where you can move your part around, you can move it up and down, and this is all connected to the table. Okay, so the reason why we're working in this way is because the Z is pointing up and down, and that is very, very crucial whenever we're working with these milling machines and setting up the simulation. Okay, so I'm just going to take these values back to 0, and then I'm just going to click OK just to see the simulation in the environment. We can see the machine now, it's been placed in. It's actually looking quite good. So let's just simulate up some of these operations we've got on the left hand side. I'll just put this probe one off just now. I'm going to press that out. And then we'll go through a process of just simulating possibly, let's just simulate up this side rough and finish just for an example. We'll simulate that up. And when it pulls in the simulation, the machine will be visible as well. So it's just importing a toolpath into the simulation as well. So it's going through a process of bringing the machine into the environment. So now, if we just slow it down so we don't miss anything, and then we can speed it up when it starts to move, we can see the simulation of the side of our rough and finish passes. And again, we still have this dialog box where we can choose what we want to see, whether it's the toolpath, the machine, the stock, the opacity, which we can increase and decrease. We can turn off the toolpaths if we don't want to see those. We can see the machine, which is the most important part of today, so we're not going to turn it off, but we can see the stock. But you can see the table moving, you can see the movement of the table, and that's why it's important, to have these machine simulations within our configurations as well. So I can only see this increasing, guys, and getting stronger, but as you can see, it's a far better environment. It's a far better way to test whether your machine's going to work in a real life scenario, with your part on the table, with the machine around it, with the limits set up and things like that. And this is just an out of the box configuration. Okay, so we can show you, or I'm going to show you today, how to build your own from scratch. Okay. So let's just close this then and get rid of this model, and we'll jump into another model and give you an idea of how it's all going to kind of come together. So because we are going to be building the machine from scratch, we do actually have to have the machine model, and you can possibly contact the vendor of that machine and get access to the machine. But we've already got a machine which is specific around the UMC 500. Alright, so this was the original model. The original model itself is basically built up of different solid bodies, and those different solid bodies can be manipulated to help you with the builder, the machine builder. But before we go any further, what we're going to do is we're going to look at how we start the machine configuration itself without the model. Okay, so how do we build a machine configuration? So if we just navigate into the manufacturing environment, what we're going to do is we're going to go up to the machine library, and within the machine library, as I say, we have got a vast amount of machines that we can use as a reference to build new machines. Autodesk are obviously trying to get to a stage where the library's the default place that you go to. It's going to be filled with the information that you need, but we can create our own machines from scratch. So we're going to look in the local environment, and you can see I've used that machine because I basically took a copy of it. So if you are inside of this environment here and you find a machine specifically around what you're looking for, you can select it, right click on it, and you can make a copy of it, and you can take it to the local environment and you can paste it there. Okay. Once it does that, it comes in, like I said, it saves the machine into your environment like it did before, and that will be available in your local environment to make edits to that machine as you move forward. Okay. But what happens if you want to create a new one from scratch? So if you want to create a new one from scratch, you'll notice you've got a plus sign at the top here in the dialog box, and that's where we're heading to add some information about our new machine. So first thing I'm going to do is click on the plus sign. When we click on the plus sign, it gives us the option of what we want to choose. In this instance, it's going to be Millen. And then we get the machine configuration dialog box up. So we configure the machine to a certain level, and then we can build the model at the back end, and then we can meet everything together to become one machine with your part in your new environment. Okay, so what we're going to do here is we're going to add some basic information, and like I said, we're going to duplicate the UMC 500 SS machine from the previous simulation that we did. So we're going to put some basic information in. So we're going to put a description in about the machine. So it's the Haas if I get that correct, MC 500, and that is going to be our SS level model. So we're going to go down to the model, and again we're just filling up the information. I'm so used to writing UNC. And it's 500, and we're going to go super speed. And then it's the vendor is obviously not Autodesk in this instance, it's Haas. And the controller that's on that is just going to be the we're going to go for the NGC. Okay, so we're adding in some basic information. We can look at the dimensions of the machine, we can look at the capabilities of the machine. So in this instance, the capabilities of the machine are crucial, so we're only working with milling in this instance. We can tell it whether it's got an automatic tool changer, whether it's got support for preload, whether it's got a number of tools, a maximum tool length, etc. So you can add this information. We can also tell it whether there's a workpiece being used and the sizes of that workpiece. It will error if there's any problems with the information that you place within here. And then the next thing we can do is we can add kinematics. So the kinematics of the machine are pretty important. And the reason why they're important is this is how you tell the machine basically how it will move using the kinematics of your X, Y, and Z, A, B, and C. Alright, so this is the part where you would go and find the specification of your machine, gather the information about how those move and the limits between those, and then import them into this area. And this can be modified throughout the process, guys. This is not something that's set in stone. Sometimes you'll put a value in and realise, oh, maybe that's not correct, or you see a mistake, and you can reiterate this at any point. So first of all I'm going to do is just introduce you to the machine. This is the Haas website. This is the model of Haas that we're looking at. We can see that the X, Y, and Z, we've got our spindle information, we've got our B-axis tilt, and our C-axis rotation information. We've got our limits that you can see, and we're going to add in some of this information about our machine. So first thing we're going to do is we can see just now that the X, Y, and Z are currently underneath the table. So what we're going to do is we're going to move the X, Y, and Z to the spindle, and then we're going to create two rotaries under the table instead. Okay, so the easiest thing to do here, guys, is just a drag and drop. So we're just dragging and dropping, making sure we've got X, Y, and then Z. And then we've got the table sitting on its own. So we've got our X, Y, Z spindle, and then we've got our table. So we're going to add 2 rotary axes to the table because it's a 5-axis machine. This machine is capable of 5 axes. So we've got a B and a C axis table, and then we've got our X, Y, and Z spindle. Okay, so we're going to right click on the table and add a rotary axis, and then we're going to do the same thing again. We're going to add another rotary axis. So our kinematics are based on the capabilities of the machine, and the information is gathered from the website and inputted into the dialog boxes that we can see here. So we're going to change that to the B, and the B axis itself is going to be within certain limits. So the first thing we need to do is we need to make sure the orientation X, Y, and Z, it's not rotating around the X. So we're going to change that value to 0, and we're going to rotate it around the Y. We're then going to add some limits, and again, all of this information I'm inputting came from the website. So it's minus 35 degrees to a maximum of 120. At the moment, we want that to go in a positive direction. So we're going to leave that on positive, and that's going to be our Y. We're going to move on to the C. So our C direction is going to be around our Z. So we can leave the Z. We've got maximum, minimum, 0, 360. We're going to change the limits to cyclic. And again, all of this information I'm changing, guys, can all be found in the help files. So if you're having real problems, remember, Autodesk have already provided you with a lot of help files that will basically iron out some of these why is she changing those values type questions. And then we can go down and look at our X, our Y, and our Z. So we'll start with the X, and the X values in this instance are basically 6, 10, and our max. And again, all these values are coming off the website. The Y is going to be 406, and the Z is going to be a minus value, so minus 406 to 0 being the maximum, because that's going to be the home position. Okay, so we can also do things like change the machining time, the coolant, and the post-processing element of it. Again, I'm going to leave that to last, okay? There is also information about multi-axes. Please be aware that you do have the option to turn TCP on and off for your rotary axis, okay? And again, that information is critical to the type of machine, and that information will be dependent on the output, okay? So I've done some kinematic changes to give you an idea of how it all works. Very simple, guys. Drag and drop, right click menu there if you need to delete or add. So we're going to say OK to that. We've got our basis of our machine. So the difference between what we've copy and pasted is there's no post selected just now, and there's no machine. Okay, so I don't have a machine. My machine builder, it's not ready just now. So that's the first stage. I found my plus sign. I've got my machine configuration to a certain level, got my information from my spec sheet, and then I can go ahead and take a look at the model. So this is the model that's basically built up. This could be a step file that's imported in from your provider, your vendor, sorry, or it could be a model that you've built from scratch and all you want to see is basically just the movement, maybe not the actual enclosure. Maybe you just want to see the movement of the heads or the table or something like that, and you don't have all of the elements of the model, but just the things that you know will move and the crucial things about your basically your machine assembly. So if we look at this model, it's built up of a lot of bodies, and those bodies are basically, if we turn them on and off, those bodies basically represent the information that we will need to control the X, Y, Z, A, B, and C. Okay, so in order for us to work with the model, it's easier if we go through a criteria which Autodesk have already set up for us to make sure that we abide by certain rules when we're working. And if you've used any other CAD application before, simplicity in these types of things is always key. So in the blog, guys, look for a link. This link will basically represent the best practices that Autodesk have introduced for this type of kind of a build, how you build up your 3D model. And it's things like making sure it's simple, Make sure there's spaces between components to stop collision, and again that's for future features that Autodesk will provide. And then the model orientation, always make sure the Z is up. The colours and appearances, again, Autodesk have given you a guide to those colours, the best colours to use. And then construction axes and work planes, turn them off, obviously, because they'll appear within your model simulation and things like that. It's best to just clean up the model. So I've stuck a link in the blog, and if you navigate to that link, it will give you an idea of the best practices of how to build your model. Okay, but things like, keeping it simple. If you've ever used a CAD application, you'll be already familiar with those types of, things anyway. So if we go ahead and look at one that I built, or I built earlier. But if we look at this one here, what I've done is I've navigated down to give you a base and a closure. We've got the B axis, the C axis, the X, Z, Y. And the reason for this is when we get to the next stage, where we need our machine builder, it makes sense to have these in a very specific way, because it will make things very simplistic when each of the component parts are dedicated to each of those axes. Okay, so again, we make the model nice and simple. We add the appearances to help. We get rid of things like constructions axis and work planes, and we keep it nice and simple. Okay, so when we've done that and we've got our model to a very simple level, what do we do next? So we've already built that machine configuration with our kinematics in the back of the machine library. So how do we link up our model with our machine configuration? And to do that, we're going to jump into the manufacturer environment, and we're going to go to utilities and look for the machine builder. And again, the machine builder has been turned on in your preferences, and it works alongside your machine configuration. So we're going to go ahead here and we're going to click on the machine builder, ribbon changes, and Autodesk have made this really very simple for you guys, and I'm hoping that you'll enjoy this environment because I like simplicity and I hope it stays this simple. So if we start from the left and work to the right, if we go select machine, this is going to open up our library, and we're going to be able to go and select that machine configuration that we chose earlier on. So we can select that machine, and then from here we work to the next stage. So we can edit the machine configuration if there's any problems, but at the moment it should be alright. We can also move components, and those components at the moment are all in the place where we want them to be, so there's no need, but we can do that if there was any problems. And then the next thing we want to do is we want to set up the machine model. Okay, so when you're setting up the machine model, there are a few things that you need to select. Alright, so just bear with me. But after you've done this a few times, guys, it really is quite simple, because all you're doing is specifying a model and then specifying a piece of geometry that will allow it to rotate around that axis or move in that linear movement. Okay, so if we select the setup for the machine model, the first thing that it asks you to do is to specify the tool. And if you think about the tool as the head of the machine, okay, so we're going to rotate the model round, and what we're going to select is the part under here which represents like the head of your machine, if you imagine. So we're going to go for the circle, and it can be the half circle here or the circle. Okay, I've chose both in the past and it still works perfectly fine. And then the next thing that we want to do is to pick a part, and the part that we're going to pick is going to be, as this image on the screen suggests, the middle of the table. So I'm going to move it around, and the selection here is going to be this circle in the centre of our table, if it allows me to select. It's been finicky today. Okay, so that's us got our two attach points, the machine head and the table. And then we're going to go through another type of selection, so things that we want to stay static. Alright, so again, this is why it's important to make sure your model is ready. So the things that we want to stay static will be the base, and if I zoom out just to give you an idea, and the enclosure of the machine. Okay, and then we're going to go through the X, Y and Z, and again we've made it really simple in the model, and simple's good. So we're keeping it really simple. We're going X, Y and Z selections X, so we're picking the X. we're going Y and we're picking the Y. We're going Z and we're picking the Z. In fact, let me just pick that Y again, just because I think I might have picked. That's correct. And then we're going to go B and C. And what you'll notice with the table is you have an extra selection, and I'm going to explain that. So we're going to go the B, and then we're going to pick the B. But when we pick the B, we need to tell it that we want it to rotate around something, okay? So if I zoom in here, you'll find there's a circle that represents the rotation around that table, and it's part of the model, okay? So you can make it part of your model geometry and make it a bit simpler for you to select, okay? So I'm going to go for the C, and I'm going to go again and pick the C, and then again I'm going to go for the centre of the table, which is there, and then I'm going to say OK. And then what's going to happen now is something that you're going to think is just, wow, do you know, it's that can't be real, but it's as simple as this, guys. Now that we have put in the limits of the head, we've put the limits of the table, and we've selected some basic geometry, and we've built our model in such a very specific way, and again with those step-by-step guides that Autodesk have given us, we're now able to flex our machine within those limits. Yeah? And I'm not going to lie to you guys, I was super impressed by this almost from the get-go, but then I'm quite sad when it comes to geeking out on new tech. So, and also I've got my rotary, and I've got my C direction as well. And I just think that's really fabulous. And I just think it's just been so simple to this stage. I haven't really done much to prep this model. All I've done is some basic solid manipulation to make sure that the components are within component sub-assembly levels, to make sure that they move whenever I move and flex the model like I'm doing. Okay. When I click close, everything will go back to its 0 position, and that is all geared towards the kinematics of the machine. Okay. So if I go and edit the machine, and remember the kinematics of the machine were the limits that you specified that came from the website, okay? So there could be specific home positions, and therefore you would apply those. These could be made like specific names. You know, again, work with the information that's there. Try your best to work around it, and if you've got any questions, you can also follow on us and we'll help. The last thing that I'm going to mention just on that note is the fact that the post processor still hasn't been added to the library either, okay? So Autodesk provides you with a library of post processors. At the moment, within your machine, you don't have a post processor attached, okay? And the reason for that is because it'll probably be your generic, you know, it'll be your generic 3-axis post that's been attached, okay? So if you need the 5-axis, there are a few things that need to be done to the generic 3-axis post to allow you to get it up to that 5-axis capability for your new HAS, okay? So if I edit this just now, just to give you an idea, under the post-processing side, there's no post-processor selected currently. And the ones within the libraries, as I say, are geared towards 3-axis machines. So in the blog, guys, I've added a link, and within that link, basically you will be able to read up on what you need to change within your configuration. And that configuration within your post is important. It's geared towards the fact that you need to add machine configuration to your post processor to allow you to have the 5-axis movement within your machine and not just the generic 3-axis movement, okay? So this is a link I've attached, guys. It's about the machine configurations. It's about the code that needs to be attached. It's about the fact that Autodesk have given you what they call the machine simulation.cps post processor, and then you have to make some changes to that post to allow it to work with your HAS 5-axis mill. Alright, so I hope that's given you an idea of how to use the machine configuration and the machine builder together within Fusion 360. Symmetry provides services, guys, for training and also for post-processing. So if you feel like a lot of this isn't, it's not second nature to use, it's not something that you feel comfortable with, especially with the post-processing side of stuff, then, feel free to contact us, lean on us. We can help and support you through a post-project as well as a training project around your CAM environment, specifically around building machines and milling as well. So again, thanks very much for taking the time to watch the video, guys. Feel free to get in touch with us, and yeah, thank you. Enjoy the rest of your day.